Speech intelligibility. Speech intelligibility, measuring speech intelligibility, factors affecting intelligibility, masking release, predicting speech intelligibility, AI, articulation index, SII, speech intelligibility index, STI, speech transformation index, and rapid speech transmission intelligibility, speech exercise. What is speech intelligibility? It's the state or quality of being understandable. Why measure speech intelligibility? We have a general model of speech intelligibility test. We have some speech material, something to tell about, some stuff, books, words, sentences. We have a talker, we have a channel, we have a listener, and we have the response for the listener. Then we can compare some speech material with the response. Speech as a function of SNRs, signal to noise ratio. Measure speech intelligibility as a function of noise, as we know, signal to noise ratio, SNR. Hypothetical of person words identified. How can we compare results across groups in a meaningful way? So we have here a graph, SNR dBs and first axis, and then percent correct for two different groups. It's a psychometric function. Measuring differences. We can have, for instance, a specific SNR dB, and then compare the two groups and see that there's a difference between the percent correct words. Yes, and and we can have also, if we want the same percent correct words for the two groups, we can see how much different in SNR is there. What do we need to, how many decibels are we needed to increase the SNR to get the same percent correct words of sentences or what it is, words. Speech reception threshold. SNR for 50% on psychometric function is called speech reception threshold. What can we measure? How can we measure it? What adaptive rules results in 50%? That should be up down. Up down. Increase after no, or down decrease after a plus. There are also other forms, 1 up 2 downs, transformed up downs med so-called transformed up down methods, adaptive methods. 1 up 2 down, then a yes means about 71%, because 1 down, a no is 50%, and P yes, P 2 yeses is a half. That means P yes squared is a half. That means P yes is a square root of a half, and is about 0.71. We can have also 1 up 3 down and 1 up 4 down, and it's more time consuming, I think, and more correct answers, and the percent of yes is also increasing. Units of different levels. There are units of written language, sentences, words, characters. There are units of spoken language, sentences, words, syllables, Phonemes. Sentences, words, syllables, phonemes. Remember that orthography is different from the acoustic. The written is different from the sound. Phonemes, we can start with this. That's the smallest sound unit of speech that separates meaning. For instance, bit contra sit, pit contra pot, cap contra cat. We can also describe them based on phonetic features. See speech production lecture. What factors might influence intelligibility? What different speech material could we use? This about the material. Yes. What do we want to measure? We can have individual phonemes, syllables, words, vocal, consonant, vocal, abba, ada, and so on. Words, whitewash, baseball, tokens produced in isolation or edited from running speech. Can be nonsense or meaningful. We can have a so-called Hagerman test with subject, verb, for instance, subject, verb, number, adjective, object. Mike, for instance, Mike won 9 white flowers, or even more unrealistic, Linda sold 14 pretty houses. Sentences have identical syntax. It could be nonsense sentences or low predictability or just low realism. And then we have some tests with carrier phrases, coordinate responses, measure. For instance, the oran, a name, and color, and number. Oran, something, oran, and blue, and number. It could be Charlie, green, and 3. And so on. Yeah. Hint or sentences list test. The shirt was out of fashion. The cat sat on the sofa. Syntax varies across sentences. Sentences are grouped into lists, phonetically balanced. Yeah. And then the context is, of course, important. If you can see there are some dots here, but the meaning of it, when you read it, can you read these sentences? Bob drove down the maybe road in his car. Language has structure and redundancy, which can be used to fill in gaps. Other materials, stories, news clips, conversations, and so on. Advantages, longer and more realistic, maybe, and disadvantages, long test times, and unclear sensitivity, maybe. Yeah. Summary about speech material. Large variety of test material, advantages versus disadvantages of all of them. Choice depends on your aim of the experiment study. Producing speech. Yeah, that means the talker. What factors about the talker could influence the intelligibility of the speech sound? For instance, effect of sex. Female talkers are easier to understand than male talkers. It shows on the graph here. The red female is higher in percent words correctness than the blue male. There is a significant difference on this graph. Long-term average speech spectrum. Now we come to long-term average speech spectrum. What is this? Spectrum of speech average across time. And we can find out, is there a difference between crosstalkers? Is there a difference across languages? Long-term average speech spectrum. We have some female and male. Frequency on the first axis, normally built up, and root mean square level in dB SPL. And we can see that from 250 to 5000 Hertz on the curve, almost no difference between females and males. But less than 160 Hertz, male have stronger level dB than female. F0 ranges differences also. Male had a bigger male had a smaller F0 ferment. This F0 frequency than women. And okay, women has about 220, and men could have maybe less. Female 210, average F0 ferments is called, and male in average 120. There are similar long-term average speed spectrum for many languages, similar in French, Swedish, Arabic, Japanese, Vietnamese, Cantonese, and so on. Long-term average speech spectrum remains roughly the same across most, maybe possible all languages. Speech level and characteristics. Lombard effect. Background noise level increases. That means people raise their voice level, and the positive slope is half dB per dB, half dB more. Raising your voice when the background noise is increasing 1 dB. In a conversation, talkers adjust to the listeners. If there's background noise, you will speak more, you raise your voice. That would say that means that when talking to a hearing impaired person, same. You can see it's the same situation. Why is the slope of the Lombard effect less than 1? A hypothetical experiment. Record speech in quiet, record speech in simulated noise, normalize to the same RMS energy, measure speech reception threshold for both types of speech. Will we find a difference? Yes. Noise-induced speech is more intelligible. People speak more clearly when there is a noise. Increased vocal efforts leads to more high frequency energy. So if you speak to a hearing impaired person, you should speak more clearly. You have some speech level used in speech intelligibility index standard. Shouting in the pressure level 82 decibel, loud about 75 decibels, raised 68 decibel, and normal 62 decibel on that. From fundamentals of acoustics, it's found in the result in this figure 27.3 is obtained when the words and the noise on a dental CD with untrained Danish normal hearing listeners. It is seen that even at a signal to noise ratio of 0 dB, almost all words are understood. It is also seen that an increase of just 10 dB in SNR can change the situation from impossible to reasonable. For instance, from minus 15 dB at 10% and to minus 5 gives 70 decibels. It's a general finding that such a relatively small improvement of the signal to noise ratio can improve the intelligibility situation dramatically. In other words, if the background noise in a room is a problem for the understanding of speech, then raise the voice.